Okay, good evening, students. So, today I thought I will get started with Newton's laws of motion. It's a easy chapter, and I'm assuming that compared to rotational motion, which we have been doing for a long time, I thought probably you folks will also feel a little more comfortable with this chapter. Okay, so laws of motion. I went through the questions in the NEET past paper. So I think, we can directly get started with the problems there. Some basics, I just want to show you what are the topics you should be aware of. So first law, inertia, and then second law, rate of change of momentum, right? And then very often they'll ask you questions based on impulse. So impulse is nothing but when the time goes on the other side, time into force will become F into delta T becomes your impulse. So change in momentum. And sometimes they will give you this kind of graph and they will ask you to find the change in momentum or impulse. So that means if you have force versus time graph, you can always find the change in momentum. Okay, so we'll do some problems. I'm sure you will get the idea. If you already have some idea, right? So definitely it will be easy only. And then these things are coming later. First, for today's problems, I think mostly you will get questions based on no impulse and first law, second law based questions. So as usual, you know where to find the past paper questions in the website, Guru Academy and Labs. So you can go there and, get the questions. So a particle of mass m is moving with the uniform velocity v1. It is given an impulse such that its velocity becomes v2. The impulse is equal to. So just now I told you impulse is nothing but f into delta t. Or you can say f is equal to mv minus mu divided by delta t. Rate of change of momentum. So delta t comes on this side. So f delta t is your impulse. So mv minus mu. Okay. Which means if I keep the m commonly out, then it will be v minus u or v2 minus v1. So that means it should be this one. And don't forget, momentum is a scalar or vector? Anybody? Any answers? So always remember momentum is a vector. So that means you have to choose this one instead of this one. Okay. A 600 kg rocket is set for a vertical firing if the exhaust speed is 1000 meters per second. The mass of the gas ejected per second to supply the thrust needed to overcome the weight of the rocket. So it may look like a very complicated problem, but it's very, very easy if you practice it. And I see many problems based on the same concept. So you know that the rocket is going upwards with the F thrust. And you know that the weight of the rocket is pulling it downwards, mg. And the acceleration is upwards, right? So this is the gases coming out, or exhaust gas. So always remember the most important formula in mechanics is sigma F is equal to ma. In this particular chapter, right? Sigma F is equal to ma. So that means F thrust minus mg is equal to ma. But then here they said to overcome the weight of the rocket. So they didn't say any acceleration. So sometimes they will say you have to accelerate the rocket at say 5 meters per second, 10 meters per second, something like that, or second square. So in that case, we will be substituting the a value here. In this case, just to overcome the weight of the rocket. So that means this part is taken as 0. As we do some more problems, I think it will make sense. So F thrust is nothing but mass into velocity minus mass into initial velocity divided by the time taken minus mg goes on the other side, so it will be mg. Initial velocity, the rocket is not initially, it's just set for a vertical firing, which means initial velocity is 0. So the gas's exhaust speed is 1000 meters per second. So that means V is given, exhaust gas. So m by T is the mass of the gas ejected per second. So that means it is pushing the gases at certain speed. Okay, so that means mass per unit time. We can call this as m dot into V is equal to mg. M dot is what is asked. V is 1000 meters per second. Mass of the rocket is 600. Gravity is, you can take it as 10. So m dot will be 6. So 6 kg per second. So that means the gases, exhaust gases will be coming out at the rate of 6 kg per second. Any questions? So take it down properly. Without the drawing, nothing will make sense. I see many questions based on the same formula or same concept. Sometimes instead of a is equal to 0, they will say it has to accelerate at a speed of acceleration should be like 5 meters per second square, 10 meters per second square, something like that. Very easy problem. Okay. Physical independence is a theory question. Physical independence of force is consequence of. So basically, the first law says that unless acted upon by an external force, it will remain at the state of rest or of uniform motion, right? Which means when there is some other force, it will get added up. So that means it's like first law is the theory here. So it's a theory question. Question is not 100% clear, but basically it says that only if you apply a force, there is going to be some kind of a acceleration. Otherwise, it will remain in the state of rest or of uniform motion, meaning at constant velocity. A satellite in a force-free space sweeps stationary interplanetary dust at a rate of dm by dt is equal to alpha v. Acceleration of the satellite is. The question itself is very confusing, right? You should know that there is something called a planet like Earth, and then there is something called a satellite going around it. When the satellite is going around it, what will happen is there will be a lot of interplanetary debris, like dust. So it will be gathering some dust from this region. Okay. In other words, it will slow down the satellite a little bit because of the interplanetary dust. So what this means is it is gathering some mass. The F is equal to ma, which we have been saying very often, which is not a 100% correct formula. Okay. The reason I say that is this is a special case. Actual formula is Newton's second law, which is rate of change of momentum. What does that mean? Rate of change of momentum means d by dt of mass into velocity. So this is the actual definition of force. So generally what we do is, I don't know if you have studied the differentiation. So you have to keep the m as such, and then we say dv by dt. But in your mathematics, you must have studied that differentiation of uv is u dv by dt plus v du by dx or dt. So that means there is one more term called v as such and dm by dt. Most of the time we forget about this term, and the reason for that is mass is generally constant in all our usual workings, right? Mass is constant, so that's why dv by dt becomes acceleration, and we kind of ignore this. However, this is not the case in spatial situation, like for example rocket. As the rocket is going out of the earth, right? So the rocket is like this. You can see that the mass, right, a huge amount of mass is going out as fuel, which means the mass is actually decreasing. So that means a satellite situation or a rocket situation where the mass is not constant, right? So take it down properly. When mass is not constant, F is equal to ma will not work. So F is equal to ma is totally wrong. So we should not use F is equal to ma. We have to go back to the basic formula, which is this one. Any doubts, anybody? Are you following everyone? Yes, no? So they said force-free space, okay? So that means There is no external force acting on the situation. So that means I can say this is 0. Acceleration of the satellite is what is asked. So that means m into dv by dt is acceleration. dm by dt, they gave it as alpha into v. That means if I want A is equal to minus alpha v square divided by m. You see, it's very easy if I know the underlying principle. Okay. If I don't know that when mass is changing, I will if I still use F is equal to ma, then it will go wrong. Okay, so that means alpha v square divided by m. I think this will be the correct answer. These things are also looking very similar, but this is the correct answer. In the case of rocket, the mass will be lost because hydrogen and oxygen will be burnt and it will be going out, which means the mass will decrease. In the case of satellite, it is gathering mass from the outside atmosphere. I should not say atmosphere, from the outside space, because there is a lot of dust in the space. So that means it's gathering some mass from there. Of course, this is going to be a very, very small mass, but still, it's a dm by dt. So with respect to time, the mass is changing. That's the meaning of this. I don't see anybody asking any doubts. I'm assuming all of you are following. Just a sec. Somebody is calling me. Just go through this. Okay. If the force on a rocket moving with a velocity 300 meters per second is 345 Newton, then the rate of combustion of the fuel. So I think we already did something very similar to this, right? So let me do the same drawing. So here they said already it's having some force is 345 Newton. So F is here. mg is down, and then it is moving with the velocity of v is equal to 300 meters per second. Rate of combustion, so I think it will be like F minus, I didn't give the acceleration. So initial velocity, you can take it as 0. So mass by time is your rate of combustion of the fuel. So that means they are asking you kg per second. Okay, so this will be 345. This you can call this as m dot. Velocity is 300. So m dot 345 divided by 300. So do the math. Any answers? 3 point something, 1.115, 1.15. So that will be my answer. They did not ask you to find the F. They already given you. They given you the F. They asked you to find the rate of fuel which you are burning, rate of combustion of the fuel. Okay. If they had given you the acceleration, then I would have taken F minus mg. So sigma F is equal to, I would have done something like, sigma F is equal to ma, like what I showed in the previous problem. So F thrust upwards minus mg is equal to ma. But in this problem, they didn't ask for that. They didn't ask for the F. They are given the F value. Any doubts? Ball of mass 150 gram moving with an acceleration is hit by a force which acts on it for 0.1 second. The impulsive force means F into delta T is equal to mv minus mu. So they are asking you to find the impulsive force. This one they are asking. So mv minus u by t is your acceleration, right? And the t is on this side. So I think acceleration is given, 150 is given. So that means 150 gram. Gram means divide by 1000 to convert it to kilogram. V minus u divided by t is 20. Okay. So that will give me the impulsive force. That will give me only the force. So 30 divided by 10. So that means it will be 3 Newton. But impulsive force means F into delta T. This is only force. So impulse, actually it's only impulse, but sometimes they call it as impulsive force. So that means F into delta T. So 3 into delta T is, time is 0.1 second. That means it is 0.3. So impulse means it should be Newton second, right? Force into time. So I think it's a printing error here. They should have given 0.3 Newton second. Any doubts? I thought I can use impulse, I can calculate impulse, but I realized that they are not given the velocity, they are given the acceleration. If they are given the initial velocity and final velocity, I can easily calculate the impulse from this. So I had to rearrange to get the force, and force into time gives me the impulse. A 10 Newton force is applied on a body produces an acceleration. So yeah, I think it's a very direct formula. F is equal to ma. So m is equal to F by a. So 10 divided by 1. So 10 kg. Okay, nothing very difficult there. Very easy. A 5000 kg rocket is set for vertical firing. The exhaust speed is 800 meters per second. So that means again do the same rocket drawing. You know that mg is acting downwards, weight. To give an initial upward acceleration 20 meters per second square. So that means there must be some F acting upwards. We call this as F thrust. An initial acceleration is given. Acceleration required is 20 meters per second square. Exhaust gas, I think it's given as 800. So m dot is 800 meters per second. The amount of gas ejected per second to supply the needed. Sorry, I think I made a mistake. M dot is what is asked, or they are given as velocity. So they are given the exhaust speed as 800 meters per second. Always remember the exhaust gas pushed backwards is what is actually pushing the rocket forward. Okay, it's like you are swimming. When you swim, you are pushing the water backwards and the water is pushing you forward, right? Newton's third law. Or momentum conservation. Momentum conservation is a consequence of Newton's third law. So as usual, as I told you, I will always use a simple formula, which is sigma F is equal to ma, F thrust minus mg is equal to ma. Since this is upwards, this will be positive. Sometimes if you had something like, acting downwards in some other, pulley problems, when it is downwards, you will get a minus ma here. But the concepts are same everywhere. So F thrust, again, mv minus mu by t. As I told you, this becomes 0 initially. and this m by t, mass by time, becomes m dot, and that is what is asked. And v is the velocity of the exhaust. Minus mg becomes plus mg on the other side, so mg plus a. ms, I think they said 5000 kg. G is 10, A is 20. So that means 5000, 10 plus 20. Speed of the exhaust gas is 800. That means I can find the m dot. That's all. So if you know these steps and this imagination, you can do this. If you don't know these steps, right, you will not be able to do this. So that means you should understand that sigma f is equal to ma, and then you should understand that mv minus ma by t. So u becomes 0, initial velocity. M by T is your mass of the exhaust gas. Sorry, rate of combustion gas flow. So I cancel with 4 and get 2 times 4 means 1, 10, 2, 5. So 125 into 3 divided by 2. How much is that? Any quick answers? Anybody? No answers. 10, 1, 7. 150 plus 37, so 187.5, something like that. Yeah, 187.5 should be the answer. Okay, so mathematics, anybody can do it, or calculator will do it, but this part you have to do it. Nobody's responding. You folks have to speak up. Okay, any doubts? Are you folks following everything? Yes, no. No doubts, sir. Okay, thank you. At least responded in the chat window. A bullet is fired from a gun. The force on the bullet is given by smudge. So listen carefully. F is a function of time t. So that means as t changes, F will also change. F is in Newton and t is in second. The force on the bullet becomes 0 as soon as it leaves the barrel. What is the average impulse imparted to the bullet? So that means they are saying that there is a gun there. So as soon as bullet leaves the barrel, right, the force becomes zero, meaning only when it is inside the barrel it can give a force with the gunpowder or whatever it is. But once it is going out, right, there is no force. It just goes on the constant velocity. So that means you should understand that. I have given it in the handbook. I showed you this. So whenever the force is not constant, the force is changing with respect to time, then I have to use this concept of integration. Okay. So what is the average impulse imparted to the bullet? So that means they're asking you to find the F dot delta T. But you can use this formula when the F is constant. When F is changing with respect to time like this, then you have to...
Sir, 0 Newton.
0 Newton. Why 0 Newton? Can you tell me why you think it is 0 Newton? I think you can try this. You have to follow this method. So when the force is changing, right? So the force is continuously changing with respect to time. So that means they are asking you to find the average impulse, meaning this area is what they are asking. Okay, so area under the curve. So I think I have to do something like from your integration concepts, you know this is delta dt. This is F. That means the area under the strip is F into dt. So that means you have to integrate it from 0 to time whenever it is, leaving the barrel. So this is your impulse. Okay. F is a function of time. So that means you see 600 minus 2 into 10 power 5 t. Unfortunately, if I put it over here, I'm not able to see the upper part. 600 minus 2 into 600 minus 2 into 10 power 5 into t. If you're not following in your maths, you will write it as y dot dx. Then you will be integrating it like this. And then you will write y is a function of x, which means you will write as x square, x cube, something like this. But here we are writing f in terms of time t, right? All the other things are same. So instead of x you have time, instead of y you have force. How do I find the time when the bullet leaves the barrel? Well, they said that the force on the bullet becomes 0 as soon as it leaves the barrel. So that means when F is equal to 0, bullet leaves the barrel. So that means 600 minus 2 into 10 power 5 into t is equal to 0. That means See, in online classes, the problem is space is always a constraint. So T is equal to 600 divided by 2 into 10 power 5. So 300 divided by 2 zeros goes away. So 3 into 10 power minus 3. Because I will be getting 2 zeros will cancel. So I will be getting 3 here. When it goes to the top, it will become minus 3. So that many seconds. So you see it's a very, very small seconds, 3 milliseconds. Within 3 milliseconds, it is leaving the barrel. Okay. So this is an important trick. They said only when you equate the force to 0, right, you will get the time. So that means you have to equate it from 0 to 3 milliseconds. So that means you have to integrate it from t is equal to 0 to t is equal to 3 milliseconds. So after that, it's simple integration. So 600 t minus 2 into 10 power 5 t squared by 2. Again, your lower limit is time t is equal to 0. Upper limit is time t is equal to 3 into 10 power minus 3 seconds. Apply the limits. If I put 0 here, everything will become 0. So I don't have to worry about the lower limit. Upper limit, I have to do carefully. I have to substitute 600 into 3 into 10 power minus 3 minus 2 into 10 power 5 into 3 into 10 power minus 3 the whole square divided by 2. So that's your answer. So that's your upper limit. Minus lower limit. Minus lower limit, I already told you it is 0, because when you substitute 0 here, everything will become 0. So simplify this, you will get the answer. So 10 power minus 3, 2 zeros, so 10 power minus 1. So this will become 18. 18 into 10 power minus 1. This will be 2, 2 cancels. 10 power minus 6 and 10 power 5, 10 power minus 1. 3 squared, it will be 9. So 9 into 10 power minus 1. 18 minus 9, it will be 9. So 9 into 10 power minus 1. So 0.9. Impulse means Newton second. So 0.9, do I have that option? Yeah. Okay. Anything not clear? Please raise your doubts. Again, I am telling you, you should know that whenever the force is not a constant, then you have to use integration method. The only trick here is integration, anybody can do it. Most of you will not know how to find the time here, the lower limit to upper limit. That means you have to equate this to 0 to find the t. And then you have to substitute it over here. Anybody having any doubts? Okay. Okay, this is a very, very common type of problem. Again and again and again, they will ask you this. Okay, I can show you this one. Look at this. So many times I have seen this kind of problems. Okay, so listen carefully. 3 kg ball strikes a heavy rigid wall with the speed of 10 meter per second at an angle of 60 degree. Okay, so very easy concept, so listen carefully. So you have a wall like this, and some ball is coming, hitting here and then going here. If this is 60 degree, you should know if this is given as 60 degree, you should know that this is 30 degree. This is 30 degree, you should know that this is also 30 degree. Angle of incidence is equal to angle of reflection. I thought it was coming like this. Okay, doesn't matter. So it's kind of coming here and then going here. So if this is 30 degree, this is also 30 degree. If this is 30 degree, this is also 30 degree. So if I consider this one, the mass, a ball with the mass m going with the velocity v at an angle of 30 degree, then you should know that this can be written as, this side it will be mv cos 30. And this side it will be mv sin 30. Similarly, if you consider a velocity coming out here, the same ball with the mass m, with the velocity, same velocity, they said same speed. So that means the velocity magnitude is same. So this is 30 degree, which means if I resolve this into two components, mv cos 30, and here this side it will be mv sin 30. Now, very important, very often used concept, so listen carefully. If you miss this, everything will go wrong. So far, I'm assuming that you are following everything. Okay, I'm just resolving this into this way, and I'm resolving this into this way. If you carefully observe, the y-axis velocity remains the same. So that means the change in momentum in the y-axis will be 0. But look at the momentum here. This is going towards right. Here it is coming towards left, which means the momentum is changed here. Okay, you should not think that this minus this is 0. That is wrong. Since the direction is changing, this will become minus. So that means this is actually minus mv cos 30. Whereas this and this will cancel each other because both are going upwards. Okay, so listen carefully. Y-axis momentum final minus momentum initial is equal to mv sin 30 minus mv sin 30, which means it is equal to 0. Y-axis. X-axis, same thing, momentum final minus momentum initial. Momentum initial is, final is minus this way. This is final, this is initial. So that means minus mv cos 30. Minus initial is mv cos 30. That means it will not cancel, it will add up. So minus 2 mv cos 30. Cos 30 is root 3 by 2. Sin 30 is 1 by 2. Cos 30 is root 3 by 2. Mass is given as 3 kg. Angle, don't forget, they are given with respect to wall, but we want with respect to x-axis. That's when I can use cos 30 and cos theta and sin theta. So 3 kg and then speed is 10. So 3 and 10. So 2 cancels, so I'll be getting 30 root 3. But then carefully listen, what we have calculated is change in momentum. So they are asking you to find the average force exerted on the ball by the wall. So that means you know that average force F is equal to mv minus mu by time t. mv is your momentum final minus momentum initial divided by time. So this we already found it as 30 root 3. If you want, you can put the minus also. Time taken is, it is hitting only for, the ball is in contact with the wall is only for 0.2 seconds. That means 2 and 30, it will become 15. So 15 multiplied by 10. So it will become 150. So minus 150 root 3. Okay. And don't forget, there is no force in the x-axis. No force. Sorry, in y-axis. Whereas there is force only in the x-axis, meaning the wall is giving the force like this. Since it is towards the left side, you get a minus. Okay, of course, they are not shown the minus here, but that's my correct answer, 150 by root 3. If you don't know this method of splitting this into x and y, you cannot do this problem. Okay, otherwise it's a very, very simple formula method. Anybody not following? So force is acting only in the x-axis, not in the y-axis. That's why the ball did not change at all. It's constantly going at a constant speed. Newton's first law. Unless acted upon by an external force, the ball will continue to move at the same speed. You see here also it is mv sin 30, here also it is mv sin 30. Then how come it is changing in the x-axis? Because some force was acting on the x-axis. That's why it is changing its path. So instead of going towards right side, it is going towards the left side now. Sometimes they will modify this question for a ball coming to a cricketer. A cricket ball is hit with a bat, cricket bat. So same concept, but you should understand that momentum is a direct. It has got direction, which means you have to take care of the angles. Any questions? Very easy problem, even though it looks very complicated, it's very easy. You will get many questions like this. If If a cricketer catches a ball of mass 150 gram moving with a velocity 20 meter per second, then he experiences a force. So the ball is coming at the cricketer, so he has to catch it, right? So once he catches it, so let's say he's catching it with his hands here. So it is coming to a stop. So that means velocity is 0. Initial velocity u is equal to 20 meter per second. 150 grams. So that means F is equal to mv minus mu by t. Or t or delta t, whatever. If it's very small, we like to write it as delta t. They're asking you to find the force. Okay, sometimes they'll ask you to find the pain experienced. Pain is nothing but your force. So mass is 150 grams. So 150 divided by 1000. Final velocity is 0. Initial velocity is 20. Divided by time is 0.1 seconds. If I do multiply and divide by 10, I will get 10 here. This will become 1 here. So that will be 3 zeros. So 3 zeros will cancel. 15 into 2, it will become 30. So do the math yourself. Okay. If you need help, I can write down the steps here. I can do multiply and divide by 10. So that this and this will become 1. And here 1, 2, 3. 3 zeros will go away. So with this 1000. So 15 into 2, it will become 30. Okay, very simple. Absolutely nothing difficult at all. Twelfth one, exactly the same thing which we did earlier, right? So I'm going to leave it to you. So 12th one, do it yourself as a homework. Sand is being dropped on a conveyor belt at the rate of m kg per second. So conveyor belt means you must have seen some, mining operations, right? You had been to Navy or, those kind of, or you must have seen the airport, conveyor bags, right? You will put the bags over here. The conveyor belt will be going in the airports and railway stations, right? So instead of bags, you are dropping some sand here. So that means the sand will be taking some mass here. So as you can imagine, as you put more and more mass, what will happen is the speed of the belt will reduce. But then read the question. The force necessary to keep the belt moving with a constant velocity of v meter per second will be. So as the sand is falling inside the conveyor belt, mass is constant or changing? Anybody? Anybody?
Changing.
Changing. When the mass is changing, are we allowed to use F is equal to ma or not? Yes, no. Can you use this formula or not? Already forgotten? What did I say?
No, sir.
Yeah. So when the mass is changing, I told you, you cannot use F is equal to ma. You have to use this basic formula. So I'm just going to copy paste from here. So I cannot use this one. So that means I have to start from the Newton's second law. Forces, rate of change of momentum. So m into v. And then you have to use your uv. Now, if you are wondering where did this come from, it's coming from your mathematics. U into dv plus v into du. This is a problem every time. And then I have to differentiate with respect to dx here. Okay. So this I'm sure you must have studied in your mathematics, u into v. So it's exactly the same thing which we are doing here. Constant velocity means acceleration becomes zero. Constant velocity. So that means the first, this term will become zero. So F is what is asked. So F is equal to V into dm by dt. So dm by dt means they are putting m kg in 1 second. So that means this is like, m per 1 second. Okay, I can take this as m divided by 1 second. So the force necessary is m into v. So that means m into v is your answer. Again, I'm telling you, if you are having some difficulty understanding this, dm by dt, what is the meaning of that? For a small time, how much mass is increasing? For a small time of 1 second, the mass is increasing by capital M. That means I have to replace this with m and this with 1 second. So that means this will become v into m. Suppose if they had given m kg for 2 seconds, then I will be substituting 2 over here in the dt place. So that means it will be m by 2. Okay, so it may look like a complicated problem, but it's actually an easy problem if you know the basic underlying principle. If you don't know this, changing mass means I should not use F is equal to ma means, then it's a very, very difficult problem. If I know this, it's a very easy problem. Okay. The handbook, I think I have not given this concept, even though I have given. So I would recommend you to not take it down properly. I forgot to give this. Maybe I'm adding it in the newer version. Okay, so here it should be like plus v dot dm v into dm by dt. And I assume that m is constant, but I think towards the end somewhere I given it for the rocket problems. Okay, even the rocket problem I have not given it. Okay. I will add it in the newer version, right? So for now, you take it down. I see a lot of problems based on this concept. Remember, we have been doing very easy problems today, okay, to get you a feel of this chapter. But, I've shown you where to start studying. This is, remember, we talked about the mv cos theta, mv sin theta, right? Coming from here, go through this. You see minus 2 mv cos theta. So definitely, if you are serious about your NEET or JEE, then before coming for the next class, you have to go through all these pages. At least some. I think we have some 4 or 5 pages. Go through this and start doing these problems. Okay. Very easy problems only, right? So you have to practice it, then come. At least my recommendation is at least some, I'm doing the second page today. First page I already completed it. So second and third, or if possible fourth page, try it and come. You have to make use of the handbook also, right? Handbook or textbook, whatever you are having, you can make use of it. Go through the handbook. If you find it useful, you can definitely use it. Okay, I think I can do one or two problems more quickly. This is also a very direct, easy problem. A body under action of force F is given, acquires an acceleration 1 meter per second is given, second square is given. Mass of the body, M is nothing but F by A. So A is 1, F you have to find the magnitude. So magnitude will be 6 square plus minus 8 square plus 10 square. That's all. You know that this is a triplet. So 36 plus 64, 100, 100 plus 100, 200. So that means root of 200. 200 means root 2 into 10, 10 root 2 kg. Okay, very, very simple problem, nothing very difficult there. A body of mass m hits normally a rigid wall. So normally means earlier it was oblique angle, something like 30 degrees, 60 degrees, something like that. Now normal means the ball is going like this, with the velocity v, and bounces back with the same velocity. So that means it's coming back the velocity v. The impulse experienced by the ball. F is equal to mv minus mu by delta t. What is impulse? F into delta t is your impulse. But have they given any force or time? Absolutely nothing. So that means nothing is given in the left hand side, but something is given in the right hand side. So that means this is your final, this is your initial. So final is minus mv minus initial is mv in the forward direction. So that means mv. That means it will be minus 2 mv. So 2 mv is your answer. The stone is dropped from a height of h. It hits the ground with certain momentum p. So that means mass into velocity with which it's coming, hitting this. If the same stone is dropped from a height of 100% more than the previous height, What do you mean by 100% more? It means 2 times the height. Okay. So if you are having trouble understanding that, that means h plus 100% of the h. Okay, so how did I get 2h? Because 100% means 100 divided by 100. So that means 100 by 100 it will become 1. So h plus h it will become 2h. Okay, so these are all the things. Sometimes you will have some confusion, but you may not be able to get it clarified. So ask your doubts, open your mouth. So this is momentum 1, mass into velocity. As you go to a higher height, the velocity will increase. So that means they're asking you more than the previous height. The momentum when it hits the ground will change by. So that means the momentum change they're asking you. So mass into velocity 2. So listen carefully, momentum when it hits the ground will change by how many percentage. So that means basically they're asking you, are they asking change in momentum? No. Are they asking fraction change in momentum by original momentum? No, they are not asking the fraction. They're asking percentage, which means I have to find the multiply by 100. So that means they didn't say exactly what they're asking properly, right? By looking at the options, you should know that they're asking you change in momentum percentage or percentage change in momentum. Okay, so that means this is what they are asking. Doing this part is very easy, provided if you had P1 and P2, right? If you had P1 and P2, I can easily do P2 minus P1 divided by P1 multiplied by 100, very easy. But how to find V2 and V1? Okay, let me quickly finish this. Okay, so V is equal to, I can try V is equal to U plus AT, but I don't know the time. But they're given you the height. So that means V squared is equal to U squared plus 2AS. U is 0, dropped. 2GH. That means you must have studied a standard formula. V is equal to root of 2GH. That means here also I can say the formula is root of 2GH. H is 2H now. It means it will be root 2 into V1. Okay. That means P1 momentum 1 is equal to M1 into V1. So there is no M1, which mass is same. So V1 is root 2 GH. P2 is equal to M into V2. P2 is nothing but this one, root 2 into V1. Or you can write it as root of 2GH. You can write it as V1 because this is also V1. So that means delta P can be written as P2 minus P1 divided by P1 into 100. This you should know or you should study it properly. That means M root 2 into V1 minus M V1 divided by M V1 multiplied by 100. M V1 will come out commonly, so it will get cancelled out. What is left is root 2 minus 1 into 100. Root 2 is 1.414 something. 41 minus 1 into 100. So 0.41 multiplied by 100 will be 41. So that means it will be 41% change. So 41% is my answer. Okay, so you should know how to find this 2H. If you have trouble, then you cannot get the correct answer. Then you should know how to find this formula and how to find momentum 1 and momentum 2. Then you should know what they're asking. This is where many of you will have trouble. So it's very, very confusing. They didn't give you properly. They should have said change in momentum means delta P. Fractional change in momentum means delta P by P. A percentage change in momentum means delta P by P into 100. So there are three different variants you should know. Okay, so I will write it down. Delta P means change in momentum. Delta P by P means fractional change in momentum. Because this is just a fraction with respect to the original, meaning P1. Delta P by P into 100. So that means, again, I'm telling you, there are so many variants, so they will confuse you with these variants. So this is percentage change in momentum. Okay, that's all. So I think very easy problems, but you should know the steps. You should know the logics. Okay, if you don't know this basics, obviously it's a difficult problem. Okay, so any doubts to be answered? If you have any doubts, please raise your doubts. Otherwise, we'll stop here. Your homework is to continue the two more pages, do it and come for next class. Okay, thank you all. Okay, so clarify your doubts, send your doubts in WhatsApp. It's up to you to make use of the resources properly. Thank you all. Bye. Okay, thank you all.